All right, let's dive right in. Today, we're going to put on our spy hats and crack a really fun coding challenge called Decode Ways. You ready? So picture this. You've intercepted a secret message, but it's just a string of numbers. That's it. Your job is to figure out what it could possibly say. And here's the tricky part. A single string of numbers could actually hide a bunch of different meanings. So let's look at an example. How many different secret messages could be hiding inside the number 11106? I mean, think about it. Is it 11106? Or maybe 111006? Right away, you can see it's not super obvious. The possibilities really start to stack up, and that's the core of what we're trying to solve today. Okay, so to crack this code, we need the key, right? And the key is actually pretty simple. A is 1, B is 2, and so on all the way to Z, which is 26. It's a straightforward map. The real puzzle isn't the map itself. It's how we decide to group the numbers we're given. Let's take a super simple example to see what I mean. The number 12. You could look at it as a 1 and then a 2, right? That gives you A and then B. Or you could see it as the number 12, which decodes to the letter L. So right there, with just 2 digits, we've got 2 totally different ways to read it. But, and this is a big but, there's a really important rule you gotta watch out for. Leading zeros. They're a no-go. So while 6 is just fine, that's the letter F, 06 is totally invalid. It means nothing. This one little rule is actually what makes this whole problem so interesting. All right, so we've got the rules, we know the main trap to avoid. Now what? How do we actually figure out the total number of ways for any given string without, missing one? Well, this is where we start looking for a hidden pattern. Let's use 226 as our guinea pig for this. It's a great example because it's small enough that we can wrap our heads around it, but it's got enough going on to show us the pattern we're looking for. The first thing we're going to do is just list out every single way we can decode it. Okay, so what are the possibilities for 226? Well, first, we could just take each number by itself. That's a 2, and a 6. So BB, F. Simple enough. What else? We could group the first 2 digits together to make 22 and then have 6 on its own. That gives us VF. And then there's one more way. We can take the first 2 by itself and group the last 2 to make 26. And that gives us BZ. So all in all, that's 3 ways. Now, did you notice something there? To figure out all the ways for 226, we kind of had to think about the ways to decode 22 and the ways to decode just 2. See that? This is the big aha moment. The answer for the whole string is actually built from the answers for the smaller pieces of the string that come before it. And this idea, this pattern of breaking a big problem down into smaller, easier problems, and then using those solutions to build up to the final answer, well, that has a name. It's called dynamic programming, and it is the perfect tool for this job. Let's dig into how it works. So with dynamic programming, the first thing we do is define what we're trying to keep track of. Let's use f of I, or f sub I, to mean the number of ways to decode the first I characters of the string. So if our string has a total length of n, then what we're ultimately looking for is f sub n. That's our final answer. Okay, so how do we calculate any f of I? It boils down to 2 really simple rules. Rule 1, look at the very last digit. If that digit is valid by itself, so anything from 1 to 9, then we can just carry over all the solutions we had from the step before, which is f of I minus 1. Rule 2. Now look at the last 2 digits. If they form a valid number, between 10 and 26, then we can also add in all the solutions from 2 steps ago, which is f of I minus 2. So the total for f of I is just adding those 2 possibilities together. That's it. So we have our rules. Now let's actually put them to work. We're going to build a little table for our 226 example and fill it out step by step. Watching it happen is really the best way to see how this logic clicks into place. Okay, let's build this thing. We always start with what we call a base case. We'll say that f of 0 for an empty string is 1. Just trust me on this for a second. It's like there's one way to do nothing, and it makes the math work out perfectly. All right, now for I equals 1. We're looking at the first character, which is 2. Is 2 a valid single digit? Yep, it's not a 0. So according to rule 1, we just take the value from f of 0. So f of 1 is 1. Moving on to I equals 2. We're looking at the second character, another 2. Again, it's a valid single digit, so we add the result from f of 1, which is 1. But wait, we also have to check the last 2 digits, 22. Is that a valid number? Yes, it's between 10 and 26. So rule 2 kicks in, and we also add the result from f of 0, which is another 1. So f of 2 is 1 plus 1, which gives us 2. Makes sense, right? 22 can be BB or V. Last step, I equals 3. We're looking at the character 6. Is 6 valid? Of course. So we add the result from f of 2, which is 2. Now we check the last two digits, 26. Is that a valid number? It sure is. So we also add the result from f of 1, which is 1. So f of 3 becomes 2 plus 1, which is 3. And that's our answer. It matches what we found by hand. It works. Okay, so we have a solution that works. It's solid. It's efficient. But can we make it even better? Of course we can. For anyone who wants to take this to the next level, there's a really clever trick we can use to save on memory. The key thing to realize here is this. To calculate any new value, say f of I, what do we actually look at? We only ever need the two values that came right before it, f of I minus 1 and f of I minus 2. We don't care about f of I minus 3 or anything earlier. And if we don't need them, why are we storing them? We don't actually need that whole array. And that one simple observation leads to a huge improvement. Instead of using an array that gets bigger and bigger as our string gets longer, which we call O of n space, we can get away with just using a couple of variables to keep track of the last two results. That's it. This brings our space needs all the way down to a constant amount, or O of 1 space. And in the world of programming, that is an awesome optimization. And just like that, we've cracked it. But here's the thing. What you've just learned isn't just a solution to one little puzzle. No way. You've basically unlocked a new problem-solving superpower. So just remember the core ideas behind dynamic programming. First, take a huge, messy problem and break it into smaller, manageable pieces. Then, solve each of those little pieces just once and store the answer. From there, you just build up to your final solution using those stored results. And finally, always keep an eye out for optimizations, ways to make your solution faster or use less space. So that is how you crack Decode ways. But the thinking shouldn't stop here, right? So I'll leave you with a question to chew on. What other tough problems, I'm talking about coding challenges or even stuff in your real life, could you tackle by breaking them down this way? Thanks for coming along in this